Welcome back to the fun field ride of question 4.5. We're going to do the same problem in a slightly different way now. So I'm going to choose three different repeating variables. And this time I'm going to read the question carefully, because it actually gives us clues as to what variables to choose. Okay, so it says at the end of the question, assume that Mach and Reynolds are insignificant, and it gives us some parameters. It gives us the diameter and the rotational rate of the prop. Okay, so we need ft to be one of our fixed variables. We'd like a dimensionless group with that in, plus the diameter and the angular rate of rotation. So we're going to choose that one and that one. As repeating variables. Now the same rules apply for repeating variables. They can't make their own dimensionless group. We need three of them in this case, and they have to include mass, length and time. And they have to be easily measurable. For diameter, yes. Rate of rotation, fairly easy to measure. And then we still need our mass term in here, so we're going to choose a density. Again, because that's the easiest one to measure. Dimensionally, it's very, very simple. Okay, those three together don't combine to make a dimensionless group. So we do exactly the same process. And then we write out the fundamental dimensions. Okay, and then we work through and equate the powers again, and like inspecting each of the fundamental dimensions. So as ever, it's easiest to start with mass and time before we do length. So A1 plus 1. The time we've got minus B1 minus 2. Then for length, this is the big one, minus 3A1. Plus C1 plus 1. Okay, work all that through, equate the powers, and we end up with the pi group. So actually exactly what we got before after we manipulated the groups. Okay, we work out the other pi groups in this. We get something slightly different than we did before. They're all still dimensionless, so don't worry. So that one stays the same. These next two are slightly different. Okay, so if you do it this way around, you can solve part B very quickly, but you could be mistaken in thinking that you've gone wrong, because you don't have Mach or Reynolds number. And again, once again, you do. It's just that they're a little bit further away, and you have to try a little bit harder to get them. So now, rather than just inverting a couple of pi groups to get Mach and Reynolds, we need to combine them again. So here's a dynamic viscosity term, and again, we need rho, v, and d here. Okay, So we need to do something with this. Again, we can use this kinematic group here, the one where we lost the mass term from. So it's kinematic in terms of length and time. Okay. So we can invert this one and then multiply them together and then invert that, and we'll end up with the Reynolds number. Okay. So hopefully you can see that. Spin that around, multiply them together. The omegas cancel. The d goes down to a single, raised to the power of 1. And then we invert the answer. So you end up with rho vd over mu. And then here is exactly the same. We can invert that, multiply it together, invert the answer, and we can get v0 over c. So we can get the Mach number. Okay, so this way round, you'll end up with that group straight away. You can plug it, you can make the big one equal the small one, put an equal sign in, put in the variables, get the answer out. There might be a slight amount of doubt you've done it wrong because you've got something that doesn't quite look like the Reynolds number and the Mach number. But again, if you look carefully, you can quite quickly see how you can get those. Okay, so the question is saying that these groups are insignificant, and this is the group that you need to use. Okay. Right. Other questions I've had is why can't you just choose anything more complicated variables as your repeating variables? Okay. Have a look at this equation here. Okay, we've got two very easy terms in our repeating variables here. Time to the -1 and length, just a single dimension. We've only got one m as well, one mass. Okay, now we could choose, so there are repeating variables, or the exotic ones. Okay, things that are highly unlikely to appear in every dimensionless group. So we could choose dynamic viscosity, force, and even density. Why not? Let's go let's go as extreme as possible. Now, when we put all these in, you can imagine the number of variables increases massively now. We've got three very, very complex, involved, multi-dimensional properties. So now when you come to solve for mass, length and time, you've not just got two masses here and 2 times, you've probably got 3 or 4. So you end up here having 3 equations that are longer than this. So that means simultaneous equations. Okay, that's going to take you a lot longer to solve. If you do this carefully, you'll still get a dimensionless group. It will be horrifically complicated, and you'll have to work very hard to get there because all of these will be simultaneous. You can't solve for mass, then time, and then insert A1 and B1 into this equation to work out C1. It's going to be a lot more involved. Okay, so that's why we always choose the simple variables, as simple as we can, whilst making sure we've got all of the dimensions in there and they don't form a dimensionless group. Okay? So the idea is you solve the problem in the most efficient manner. Okay, so you can do this in many, many, many different ways. But those two that I've looked at are probably the most simple. Okay, in terms of we get a solution both ways relatively quickly. Okay, so don't make it harder than it needs to be for yourself. Okay, so that's the end of question 4.5. Done it 2 different ways. If you can't sleep, feel free to have other goes, and why not try really difficult ways with really, really complex repeating variables and see if you can do it before you fall asleep. All right, I'll see you next time.